Corporation, USA, told from its beginnings to its global dominance in technology today. NVIDIA Corporation, the long story. The beginning, 1993, the dream starts. NVIDIA was founded on April 5th, 1993 in Santa Clara, California, USA. Its three founders were Jensen Huang, a Taiwanese-American electrical engineer and still CEO today, Chris Malachowsky, an engineer from Sun Microsystems, Priem, a computer graphics expert. Their goal was to create a graphics process GPU that could make computers display high-quality visuals faster, something essential for gaming and design. At that time, the idea was risky. Few believed that graphics chips could become a big business. The first steps, 1995 to 1998. In 1995, NVIDIA released its first product, the NV1 chip. It could handle graphics, sound, and input, all in one. However, it didn't perform well commercially. The company nearly failed. But in 1997, NVIDIA introduced Riva Hunt 128, a faster, simpler, and cheaper graphics card. This time, it became a huge success, putting NVIDIA on the map of serious gaming hardware companies. 3. The GeForce Revolution, 1999 to 2006. In 1999, NVIDIA launched the GeForce 56, the world's first GPU, graphics processing unit. It could process 3D graphics in real time, giving gamers realistic shadows, lighting, and movements. A huge leap forward. This single product changed the gaming industry forever. In 2000, NVIDIA acquired 3DFX, another graphics company, becoming the most powerful GPU maker in the world. It also signed a deal with Microsoft to supply graphics chips for the original Xbox console. By 2006, NVIDIA introduced a new technology called CUDA, Compute Unified Device Architecture. CUDA allowed GPUs to be used not just for gaming, but for scientific computing, artificial intelligence, AI, and data processing, laying the foundation for the AI revolution that would come later. The rise of the GPU era, 2007 to 2015. NVIDIA kept improving its GPUs, GeForce, Quadro for professionals, and Tesla for high-performance computing. While competitors like AMD tried to catch up, NVIDIA's CUDA system made its GPUs more useful in new fields like machine learning, climate modeling, scientific research, cryptocurrency mining. It became clear that NVIDIA was more than a gaming company. It was transforming computing itself. 5. The AI and deep learning revolution, 2016 to 2020. By 2016, artificial intelligence, AI, and deep learning were exploding. NVIDIA's GPUs were perfect for training neural networks. They could process thousands of operations at once. Companies like Google, Amazon, Tesla, and Facebook started using NVIDIA GPUs for their AI models. In 2017, NVIDIA became the most valuable semiconductor company in the US. It powered self-driving cars, robotics, and supercomputers. The NVIDIA DGX systems and NVIDIA Drive platforms became popular among AI researchers and automakers. During this time, NVIDIA's stock price began to soar, turning it into a Wall Street superstar. 6. Expansion and acquisitions, 2020 to 2023. NVIDIA tried to expand further. In 2020, it announced plans to acquire ARM Holdings, a British chip designer, for $40 billion, but the deal was blocked by regulators in 2022. It continued acquiring smaller AI and networking companies like Mellanox Technologies, a key player in data centers. At the same time, NVIDIA's RTX series, GeForce RTX 20, 30, and 40, introduced ray tracing, a technology that makes lighting and reflections in games look lifelike. The RTX 4090, for example, became one of the most powerful gaming GPUs ever made. The AI boom and record-breaking growth, 2023-2025. When AI tools like ChatGPT appeared, NVIDIA became the backbone of the AI revolution. Every major AI company, OpenAI, Google DeepMind, Meta, and Microsoft, used NVIDIA GPUs to train large language models. Its data center chips like A100 and H100 became as valuable as gold in the tech industry. By 2024 to 2025, NVIDIA's market value surpassed $3 trillion, making it one of the three most valuable companies in the world alongside Apple and Microsoft. Jensen Huang became one of the most admired CEOs in the tech world, known for his leather jacket and futuristic vision. debate today and the future, 2025 and beyond. In 2025, NVIDIA continues to lead in artificial intelligence, data centers, gaming, self-driving vehicles, robotics, 3D simulation, omniverse. The company is working on new AI superchips and platforms that will power AI factories, systems that can generate worlds, models, and intelligent machines. Its mission today is clear, open quote, to fuel the next industrial revolution powered by artificial intelligence, close quote. Quick computing, HPC. Unlike CPUs, which are optimized for sequential processing, GPUs excel at parallel processing, making them ideal for supercomputing tasks like simulations, AI, and scientific research. And NVIDIA enters the supercomputing space. By the mid-2000s, NVIDIA realized that the massive parallelism of GPUs could transform computing beyond graphics. They started pushing CUDA, Compute Unified Device Architecture, in 2006, a revolutionary platform and programming model that allowed developers to harness GPU power for general-purpose computing, not just graphics. CUDA essentially turned NVIDIA GPUs into supercomputer accelerators. Researchers and engineers could now use NVIDIA's hardware to perform complex calculations in physics simulations, climate modeling, molecular dynamics, and AI and deep learning. The Titan era! In 2012, NVIDIA launched the Tesla K20 GPU, designed specifically for HPC workloads. Tesla GPUs were installed in supercomputers around the world, providing massive speedups compared to traditional CPU-only systems. For example, Oak Ridge National Laboratory's Titan supercomputer integrated more than 18,000 NVIDIA Tesla K20X GPUs in 2012, making it one of the fastest supercomputers in the world at the time. Titan achieved 17.59 petaflops of computing power, a combination of CPU and GPU performance, demonstrating the true potential of hybrid supercomputing. #AI revolution and NVIDIA's dominance. As AI and deep learning rose in the 2010s, NVIDIA's GPUs became central to this field. The reason is simple. Deep learning algorithms require massive parallel computations, exactly what GPUs were built for. Key moments in NVIDIA supercomputing history during this phase include 1. Volta architecture, 2017, introduced tensor cores, specialized units designed specifically for AI training and inference. This accelerated neural network computations by several orders of magnitude. 2. DGX systems, 2016 onward. NVIDIA released purpose-built supercomputers like the DGX-1, a complete AI workstation combining multiple GPUs with high-speed interconnects and optimized software. These became popular in universities, labs, and corporate AI research centers. 3. NVIDIA GPU Cloud, NGC. NVIDIA created a cloud ecosystem to let organizations deploy GPU-accelerated workloads without building physical supercomputers. Leading the exascale era, the 2020s brought the challenge of exascale computing, systems capable of performing a quintillion calculations per second. NVIDIA has been at the center of these efforts. Hopper and Ada Lovelace architectures. These GPUs power top-tier supercomputers with AI and HPC convergence, capable of handling scientific research, energy simulations, weather forecasting, and more. Frontier supercomputer, Oak Ridge 2022. NVIDIA GPUs help power the first US exascale supercomputer, achieving over 1 exaflop of peak performance. NVIDIA's role in supercomputing has shifted from just hardware to a full-stack ecosystem. Hardware, GPUs, software, CUDA, DNN, Triton, AI frameworks, and cloud deployment. Researchers can now run AI training, molecular simulations, climate predictions, and physics modeling on the same NVIDIA platform. Global impact today. NVIDIA GPUs are found in the fastest supercomputers around the globe. Examples include Summit, Oak Ridge, USA, hybrid CPU-GPU system. Fugaku, Japan, uses NVIDIA GPUs in some AI-related tasks. Selene, USA, one of the fastest AI-focused supercomputers. NVIDIA has become synonymous with GPU-accelerated supercomputing, AI research, and cutting-edge scientific discovery. Their GPUs are no longer just gaming cards. They are the backbone of modern HPC and AI, helping scientists simulate the universe, fight diseases, and design next-generation technologies. The vision ahead. NVIDIA CEO Jensen Huang envisions a future where AI supercomputers are ubiquitous in labs, hospitals, corporations, and even smaller institutions via cloud services. The company is also exploring quantum computing integration amid further pushing the boundaries of what a supercomputer can do. With each new architecture, NVIDIA not only increases raw computing power, but also enhances energy efficiency, scalability,